Right, hello everybody. Hello again. Just wanted to invite you into this next new video. This will be our video number 2. Here's where we start talking about objects in motion. So far, we've really only been concentrating on objects in what we call equilibrium. And for the most part, we've been talking about objects that weren't moving. Although there are cases where equilibrium exists with objects in motion, we've really basically been talking about objects that weren't moving in the frame of reference. But now we're going to see objects start to move. And so we need some definitions, we need some terms in order to explain what objects are doing. First one, speed. Okay, I think most of us understand this. Unfortunately, too many of you people like to experience this when you're driving, but speed is a way that we describe an object when moving. Distance divided by time. Okay, distance divided by time. How much ground is covered, and how long does it take to cover that ground? So for example, we might say meters, okay, because obviously we're going to use the metric system when we do science. Meters per second, for example. Most often in physics, this will be the unit that we're using, meters per second. But you might be more familiar with miles per hour, right? Because when you're driving, there's this object on the dashboard. You might have seen it before. Then again, I've seen you guys drive, so maybe you don't know this exists. There's this thing called the speedometer. It tells you your speed. There's also these signs on the side of the road that tell you what is legal, and you may not travel faster than that. Anyway. So speed, I think we get speed, we've seen that. But we're going to make a distinction between the term speed all right, so speed is distance divided by time. Now we're going to introduce another term that we use in physics a lot called velocity. Many things are going to seem the same here. All right, so displacement. Displacement is another word that we use to explain a amount of meters, feet, inches, miles, some sort of distance. But the difference between distance and displacement is displacement, we need to know kind of what direction we're going, because what's different about velocity is a measurement of some sort of movement away from a starting point divided by how much time it took, but the other important component is the direction. What is the direction that this motion occurred in? So for example, we might say meters per second north. We could say meters per second to the right, okay? It just depends, okay? It depends on whatever your frame of reference is and whatever you've set up as the coordinate system, but you have to indicate that with some sort of direction. So much looks the same because it's still some sort of how far away did you go and how much time did it take you to get there? But we need a direction as well. For it to be velocity, it has to have a direction as well. That's because we call velocity a vector. Okay, it's just a term that means it has a magnitude, some sort of number, some sort of meters per second. Could be 3.0 meters per second. Okay, so 3.0 meters per second, that's the magnitude of this velocity, but the direction is also important. That's what makes it a vector. It's a little more specific. It's telling us what direction the motion occurred in. All right, quick pause to erase the board. All right, board good and erased. Now, next term. Feel free to rewind if you didn't get the vocab. Of course, pause at any point during a video if you need extra time to write something down. Next term, acceleration. Okay, so acceleration is really just how quickly does the velocity change. Okay, we would define it as rate of change of velocity. Okay, how quickly does velocity change? All right. Typically, if you're a car person, you think about the acceleration. You sort of judge acceleration on how far back in the seat does the car throw you when you hit the gas, right? I mean, feel that acceleration, man, right? So yeah, that's kind of sort of it. Yes, that's true. But more of a sciencey kind of a physics definition, the rate of change of the velocity. Now, we're going to say acceleration, signified by a letter A, equals the change, Greek letter delta, okay? We'll see it a lot in physics. The Greek letter delta just means change in something. When a quantity changes, we put the Greek letter delta. Could be positive change, could be negative change, increasing, decreasing. It depends. But the Greek letter delta, it just indicates a change in something. So the change in the velocity, the delta V divided by the time. So because for a rate to happen, you have to incorporate an additional unit of time. Velocity already had time in it. We already saw that time is part of velocity, but now we're saying how quickly does velocity change? How much time did it take to go from 0 miles an hour to 30 miles an hour? That's a measurement of the car's, for example, acceleration. But let's look at how this breaks down, because velocity can be measured as meters per second. So let's go back to meters per second, because it's more like most of the physics problems we're going to do. The final velocity, V subscript F, minus the initial velocity. We're going to use the same terminology as the workbook problems that you're going to be seeing a lot of. Initial conditions are signified by a little subscript 0 or naught. Okay, V naught is the initial velocity. VF is the final velocity. Final minus initial divided by the time it took to do that change. So you're going to end up with some number of meters per second. So like that example I just said, a car goes from 0 to 30. Okay, we want to know what the acceleration of this vehicle is. How long did it take to do that acceleration? Let's say it takes 5 seconds to do that acceleration. So initial velocity, 0 meters per second. Final velocity, oh, no, we didn't do miles. We were doing miles per hour, my fault. I forgot. 0 miles over hours, okay? And final velocity, we said, was 30 miles per hour. How long did it take to do? We just made up a time of 5 seconds. So how quickly does it take this? What is the acceleration of this car to go from 0 to 30? If it takes 5 seconds, what is that rate of change? What is that acceleration? So now I'm going to plug in these numbers into this formula. I'm going to change to blue because I'm substituting stuff in. So final velocity, 30 miles over hours. Not equals, minus. 30 minus 0. All right, so the final velocity, the initial velocity, 30 minus 0, and the time it took to do it, we said 5 seconds. All right, so a pretty easy little calculation here. 30 minus 0, easy. Divided by 5, hopefully also easy. It's 30 miles per hour minus 0 divided by 5 seconds. I don't really like I don't really like problems like this. A lot of my units are in different measurements. Let's go with it for now, but we're gonna work on converting a lot of units together. We're not gonna use a whole lot of changes in units, okay? But it's 30 miles divided by 5 seconds. This car is changing its amount of miles per hour. It's changing its number of miles per hour by 6 miles per hour every second, right? So the final answer here, it changes 6 miles per hour per second that it accelerates. Every second, it's going 6 miles an hour faster than the previous second. So after 1 second, this car is now going 6 miles an hour. After 2 seconds, the car is going 12 miles an hour. And we're not just doubling, we're only adding 6 more, okay? So be careful. On the 3rd second, okay, the car is now going 18 miles an hour after 3 seconds of this acceleration, okay? So it's changing by 6 miles an hour every second. So it gets faster by 6 miles an hour every second. So we would say the acceleration of this car, it adds 6 miles an hour every second that it travels. But technically, because we're using velocities and accelerations, we should have directions. So we're going to say south. Okay. So I should have included south. All right, because an acceleration, because it's made from a velocity, also is a vector. All right, that's all for this video today. We got more videos coming on motion. We'll see you next time.